Welcome to Daily Papers, the podcast where we break down the latest fascinating research into bite-sized pieces. Today, we're diving into the weird and wonderful world of how AI sees things. Specifically, we're looking at a paper that asks a deceptively simple question. If you want an AI to understand a picture, should you give it the best, most crystal clear photo possible?
You'd think the answer is an obvious yes, right? The better the photo, the better the AI will do. It just makes sense.
It does make sense, but what if I told you that for some of the most advanced AIs in the world, the answer is no? What if sometimes a blurry, noisy, or foggy picture is actually better?
Wait, really? That sounds completely backwards, like trying to read a book by taking your glasses off.
Exactly. And that's why the researchers call it the visual quality paradox.
Okay, so before we get into the paradox, let's set the stage. We're talking about a specific type of AI called a multimodal large language model, or MLLM for short.
That sounds very technical. Let's break it down. You've probably heard of large language models like ChatGPT, which are amazing with words. A multimodal model is just the next step up. It can understand more than one mode of information. It can process both text and images.
So you can show it a picture of a cop playing a piano and ask what's funny about this image, and it can understand both the visual information and the question to give you an answer.
Precisely. These MLLMs are getting incredibly powerful. But this paper, titled Demystifying the Visual Quality Paradox in Multimodal Large Language Models, points out a huge blind spot in our understanding of them. We assume they see like us.
So the researchers decided to put that assumption to the test. They took several of these top-tier AIs and gave them a bunch of visual quizzes. But here's the twist. They deliberately messed with the images.
Right. They took perfectly good photos and systematically degraded them. They added digital noise, like TV static. They added motion blur, like you'd get from a shaky camera. They made them out of focus. They even added fake snow and fog.
The goal was to see how much the AI's performance would drop. But that's not what happened, is it?
Not always. For some tasks, especially ones that required complex reasoning, the AIs didn't just do okay, they actually got better. Their accuracy went up when looking at the worse image.
That is wild. How is that even possible?
The paper offers a really cool explanation. Think about a perfect, super sharp, high-resolution photo. It contains a massive amount of information: the texture of the leaves, the reflection in a window, a tiny sign in the background.
Most of which might be completely irrelevant to the question you're asking. It's just visual clutter.
Exactly. And the theory is that a little bit of blur or noise can act as a filter. It strips away the distracting, high-frequency details and forces the AI to focus on the bigger picture, the main shapes, the important objects, the semantic content, as the researchers call it.
So it's kind of like when we squint our eyes to see the general shape of something far away, we're intentionally reducing the detail to see the main form.
That's a great analogy. And what's even crazier is what happened when they tried to fix the problem the old-fashioned way. They took the blurry images and ran them through AI-powered image restoration tools, the kind of thing that can magically de-blur or de-noise a photo.
Okay, so they give the AI a perfectly restored, clean image. That must have worked, right?
Nope. In many cases, it made the AI's performance worse than just giving it the original blurry image. This really hammers home the point: what a human considers a high-quality, aesthetically pleasing image is not what the AI considers high-quality, useful data. There's a fundamental mismatch.
So if we can't just clean up the images, how do we solve this? How do we help the AI perform its best, especially when real-world images from cameras or sensors are often imperfect?
This is where the paper introduces its big idea, a clever tool called Visual Quality Test Time Tuning, or VQTTT for short.
Another mouthful. Let's get an analogy for that one.
Okay, Imagine VQTTT is like a personal image consultant for the AI. It sits between the image and the AI. For every image in question, it makes a rapid decision. It says, okay, the AI is trying to answer a math problem from this textbook image. For this, it needs to see the text clearly, so I'll sharpen the input a tiny bit.
Or it might see another image and say, the AI is trying to identify the main animal here. All this background grass is a distraction. Let's blur it just a little to make the main subject pop.
Exactly. It's an adaptive filter that tweaks each image on the fly to match the AI's secret preferences for that specific task. And the best part is that it's extremely lightweight. It's a tiny module that you can plug into existing AIs without retraining the whole giant model.
So it's a small, smart, and fast solution. And the results, did it work?
It worked like a charm. Across the board, adding VQTTT boosted the model's performance, making them more accurate and robust, especially on the tricky, degraded images.
This feels like a really important shift in thinking. For years, the mantra in AI has been better data, better data, better data. And we've always assumed better means cleaner and higher resolution from a human perspective.
Right. This paper argues that we need to redefine better. As the authors put it, we have to remember that in this new era, AI is the main data customer. We need to start preparing data for its preferences, not our own.
The real-world applications seem huge. Think about a self-driving car trying to navigate in heavy fog, or a medical AI trying to read an X-ray that isn't perfectly sharp. A system that can adaptively tune the image it's seeing could be the difference between success and failure.
Absolutely. It's not about making the fog go away. It's about helping the AI see through the fog more effectively.
So to sum it up, AI doesn't see the world like we do. Sometimes a bad picture is a good picture for an AI because it cuts through the noise.
And by building small, smart tools that act like a pair of adjustable glasses for our models, we can make them much more effective and reliable in the messy, imperfect real world. A fascinating look into the mind of the machine. That's all the time we have for today.
Thanks for listening to Daily Papers.